I'm sorry, sir. Can you repeat the question? I didn't get.
There are some protocol running at transport layer. Just I am asking you which protocols is working at application layer. How many protocol are there at transport layer? And what is the difference between? Actually, there are two protocol.
Two types of protocols, so TCP and UDP.
Yes, TCP and UDP. So may I know the difference between TCP and UDP?
TCP is a connection oriented. UDP is connection less.
Okay, what do you mean by connection oriented and connectionless?
It's like connection oriented. Like we will need it's like confirmation from the client. It's like from server. But like UDP, there is no any acknowledgement. Like there is no any handshake. I think 3 handshake way in the UDP.
Three-way handshake.
Yeah.
With the help of three-way handshake, machine will stabilize the logical connection.
Okay, in 3-way, I think first we will sync SYN.
Okay.
And then from the server, we will get the acknowledging, and after that, we will send the data like in the third.
Okay. Anything else? First difference is TCP is a connection oriented.
And UDP is a connection less.
In TCP, the main purpose is if any packet is lost, means it is the recall that packet.
Retransmit is possible in TCP.
Yes, sir. Retransmit.
Okay. Second difference is
it's a reliability in connection.
Okay.
Yeah, reliability.
Not possible in UDP. Anything else?
UDP is fast as compared to TCP.
Okay, TCP is slow and UDP is fast. Okay, anything else?
TCP is updated like source and destination, random port number, and the port number is 179.
No. Those are different things.
Okay.
May I know the protocol number of TCP?
179, sir.
No. That is protocol number of BGP.
So TCP port number is 179, right?
No.
21, 23.
No. Wait.
No,
Any other difference, guys? Any other difference? So there is one term in networking called windowing. Windowing. So windowing is done in TCP and windowing is not possible in UDP. In TCP only. So now question is, what is windowing? Anyone have any idea about windowing? Very popular term it is in computer networking.
Sir, windowing like that our OS, right? Window is nothing but we are run our system in the OS.
Okay, see, suppose I have one computer over here and I have one server. Both are suppose directly connected. Server. Okay, suppose IP address of this server is 10.1.1.1 or 2/24. IP address of this computer is, let's say, 10.1.1.1/24. Done. Now suppose this is my HTTP server. Okay, name of this server is, let's say, www.pmnet.com. Okay, so I want to access
सर सर्वर और
www.pmnet.
कंप्यूटर की आईपी सेम ही रहेगा.
IP is different. Here computer IP address is 10.1 and server IP address is 10.2.
ओके सर.
Okay, so when I will type www.pmnet.com in browser on this machine, what will happen? This machine will generate one HTTP request. Yes,
HTTP.
Yes.
HTTP
Yeah, I'm
request.
sorry. Sir, is this recording on?
Oh, great.
Thank you.
This machine will generate a HTTP request. After that, this request will be generated at this computer on which layer, guys? At which layer? Yes.
एप्लीकेशन लेयर सर.
At application layer, this machine will generate one HTTP request. After that, application layer will hand over it to presentation session. I am skipping those two layers. Okay. When transport layer will receive this actual data, what this computer will do at transport layer, this machine will send one SYN message first. Yes or no? One SYN message. Then server will send one SYN plus ACK. And then again, computer will send one ACK. Yes, this is what three-way handshake. Done? Done?
सर
Now,
लास्ट पॉइंट ये देता है ना कि मैंने मैसेज रीड कर लिया.
yeah, exactly. This is your SYN message. SYN means you can say hi. This is SYN plus ACK means hi, and I receive your hi as well. And last one is ACK only. Yes or no? This
Yes,
is
sir.
three-way handshake, and through three-way handshake, both machine will build a logical connection. After that, this computer will start sending actual data. Yes or no? Actual data is my HTTP data. Suppose this computer have 100 packet. How many packet? 100 packets that this computers need to send to the server. So suppose this computer have sent packet number 1 first. After that, it will wait for acknowledgement. Yes or no? It will wait for acknowledgement. When it will receive acknowledgement from server, then it will send second packet. So acknowledgement is required, then server will send one acknowledgement on same acknowledgement number. Suppose in the first packet sequence number was 1, so server will generate reply on acknowledgement number 1. Okay. Then again computer will send second packet, and again it will wait for acknowledgement. Yes or no? So here say, let's say sequence number is what, 2. So server will send acknowledgement on what acknowledgement number 2. Yes or no, guys? Is flow clear to everyone? Then computer will send third packet. Let's say sequence number in third packet is 3. Again server will send what? Acknowledgement. So like this, if server will send acknowledgement after every packet, then communication will be very slow. Yes or no?
Yes, sir.
Then communication definitely. Suppose computer need to send 100 packets. So every time computer will wait for acknowledgement, then it will send next packet.
True.
Then communication will be very slow. So this is very slow process. So that's why we come up with technique called windowing. Now what is windowing? So windowing, I am getting my voice back.
No, sir.
Windowing is the technique to reduce the number of acknowledgement in TCP. Okay, now how windowing reduce the number of acknowledgement? See guys, while three-way handshake, both router will negotiate their buffer memory. What I am saying, while three-way handshake, both machine will negotiate their buffer memory. You all know about buffer memory. What is buffer memory? Whenever your machine will receive
It's
data,
temporary
first of all,
memory.
yes, temporary memory. Suppose your computer is receiving some data first. Before executing the data, machine will store the data in buffer memory for very few seconds. Yes or no?
Yes, sir.
So both, while three-way handshake, both machine will negotiate their buffer memory. Now computer have knowledge about the buffer memory of server, and server have knowledge about the buffer memory of computer. Done? On the basis of buffer memory, both will decide one window size. Both will, let me write over here, while three-way handshake, sender and receiver will negotiate a windows size on the basis of buffer memory. Let's say this server can store 5 MB data in their buffer memory. What I am saying, let's say server can store 5 MB data in their buffer memory, and size of one packet is, let's say, 1 MB. So how many data, how many packets server can store in buffer memory, guys? Size of one packet is 1 MB.
Then there will be 5.
Yes.
5 MB.
So server can install, server
Five.
can store 5 packets in their buffer memory. Yes or no?
Yes.
So now both will negotiate the window size will be what? Window size will be 5. Done?
5. Yes, sir.
So now window size is 5. That means this computer will expect acknowledgement after sending 5 number of packets. What I am saying? This time, again, this is my computer and this is my server. Again, this computer need to send 100 packets. Done. And window size is what? Window
5.
size is 5. Okay. So first computer will send one packet number 1. It will not expect acknowledgement. When it will expect acknowledgement? After 5 packets. After 5 packets. Because window size is 5. So receiver machine will send acknowledgement after window size. So window size is 5. That means when server will receive 5 packets. Now
Yes.
server don't have capability to store more packet in their buffer memory. Yes or no?
Yes, sir.
So okay, now in the buffer memory of server there are 5 packets. So server is going to send one acknowledgement. Now before acknowledgement, see the sequence number. While sending data, computer will put sequence number as well. we will understand how many information computers will add at transport layer in the TCP header. So let's say sequence number of this packet is 1, sequence number of this packet is 2, sequence number of this packet is, let's say, 3, sequence number of this packet is, let's say, 4, and sequence number of this packet is, let's say, 5. One, 2, 3, 4, and 5. Now computer is expecting what? One acknowledgement from the receiver. So definitely receiver is going to send one acknowledgement. On what sequence, on what acknowledgement number it will send acknowledgement?
5.
5.
First.
That means 5. I have received your 5 packets.
5 packets.
Now once computer will receive this acknowledgement from computer, again computer will send how many packet? 5 packets before acknowledgement. On sequence number what? Sequence number 6, sequence number 7, 8, 9, and 10. Then again computer will expect acknowledgement. So definitely server will send acknowledgement. Now server is sending acknowledgement after 5 segments. So you can see we have reduced the number of acknowledgement, yes or no? Earlier server receiver machine was sending acknowledgement after every packets, and now receiver machine is sending acknowledgement after window size. Yes or no? So what is windowing? Now windowing is a technique which is used to reduce the number of acknowledgement. That's it. Done, guys? Done?
Yes,
So
sir.
windowing will done in TCP only, not in UDP. So in case of UDP, suppose I have one computer over here and one server, and this time my service is UDP based, not TCP based. So suppose buffer size of the server is again 5 MB. Server can store 5 MB data in their buffer memory, but computer don't have knowledge about the buffer memory of server, yes or no? Because here we don't have three-way handshake. So computer is directly going to send data, yes or no? So there is chance that computer can send the data whose size is larger than the buffer memory of server. Then server will do what? Server will simply discard the data. Whenever server will receive the data whose size is greater than their buffer memory, server will not execute that data. Okay. So by using TCP, I am going to send 100 packet. From here I am going to send 100 packet to this server. Without acknowledgement, computer will send how many packet? 100 packet. Yes or no? Suppose due to congestion on the link, this server have not received packet number 3. Server have not received this packet. Okay. So computer will never get to know about the missing packet on server. Yes or no? So computer have sent all 100 packet, and then server will not receive, packet number 3. So how server can execute the packet? Not possible. So again computer need to send the entire data again, 100 packet again. If any packet will miss on the link or server will not receive, then computer need to send entire data again. Yes or no? Because there is no any information on computer that how much data server have received. But in case of TCP, machine have knowledge that how many data server have received, because computer is getting what? Acknowledgement from their receiver machine. So in the TCP, Fourth difference is missing data can be retransmitted in the case of TCP. Missing data cannot be retransmitted in case of UDP. In case of UDP, you have to retransmit the entire data. Suppose in TCP, server will not receive packet number 3. So when server will give acknowledgement to computer, it will not send acknowledgement on acknowledgement number 5. Then it will send acknowledgement on what acknowledgement number? It will send acknowledgement on acknowledgement number 3. So once computer will receive an acknowledgement from server and they will check the acknowledgement number is 3. Oh my god, I was expecting acknowledgement at acknowledgement number 5, but I am getting acknowledgement at acknowledgement number 3. That means server have not received packet number 3. So it will retransmit only packet 3. Done. This is also a difference between TCP and UDP. Okay guys?
Yes, sir. Clear.
So here also you can see the difference. Connection oriented, connectionless. We can arrange receiving traffic in sequence in TCP, but we cannot arrange the receiving traffic in sequence in case of UDP. What do you mean by this? Suppose now from this computer to server, I am going to send suppose 3 packet. 3 number of packet. In packet number 1, packet number 2 and packet number 3. Suppose in packet number 1, suppose I'm sending 4 packet to server. In packet number 1, my actual information is, let's say hello. In packet number 2, my actual information is how. In packet number 3, R. And in packet number 4, U. This is my actual information. My actual information is what? Hello, how are you? Yes or no?
Yes, sir.
Clear, guys? Now, in TCP protocol will do what? TCP protocol will put sequence number here. Here sequence number will be what? 1. Here sequence number will be what? 2. Here sequence number will be what? 3. Here sequence number will be what? 4. Okay. So definitely computer will send packet first, packet number 1 first, then packet number 2, then packet number 3, then packet number 4. Done. Suppose due to congestion on the link or because of any reason, this server have received segment number, packet number 3 first. So in the packet 3, what is information? R. Yes or no?
Yes,
Then
sir.
it have received packet number 1. So here information is what? Hello. Then in packet number 2, how? Then in last packet, you. Yes or no?
You.
So in case of
Okay.
UDP, this is your actual information, because UDP does not have any information about sequence number. Sequencing is not there. So according to UDP, this is your actual information. R, hello, how you? But you are using what? TCP. So all packets have what? Actually, these are segment. All segment have the sequence number. Here sequence number is what? Sequence number is 3. Here sequence number is what? 1. Here
1,
sequence number is 2.
2,
Here sequence number is
4.
4. So TCP can arrange the receiving data in actual format. Then information will become what? Hello, how are you? But according to UDP, information is R, how, R, hello, how you. Yes or no? So this is also a difference between TCP and UDP. Is it clear? So we can arrange the receiving data in case of TCP with the help of sequencing, but we cannot arrange the data, receiving data in case of UDP. Retransmission can be done. We had discussed this. After that, TCP is reliable. Reliable means the communication where we have acknowledgement. That type of communication is reliable. Reliable means sender machine have knowledge about the received data. That receiver machine have received it or not. So yes, if there is acknowledgement, that means TCP is reliable and UDP is not reliable.
So,
Yes.
somewhere we also read that TCP is more secure as compared to UDP. So I think they have no security concern.
No problem. What SAR is setting means reliable means if any packet loss means it will be
No, I'm
retransmitted.
getting this point. I'm getting, but somewhere also
No.
we
There
read
is
this.
no any relation between
Will-
security and TCP UDP,
Yes,
brother.
correct.
Security is different thing.
It's
Okay.
not a secure, bro. TCP is not a
No.
secure.
If someone is telling that TCP is secure and UDP is not secure, definitely he is wrong. Okay. So these are difference. Here are some more difference. Default header size of TCP is 20 byte and default header size of UDP is 8 byte. This is also a benefit of UDP. After that, the some application layer protocols which uses TCP and which uses UDP. So HTTP, HTTPS, Telnet, SSH, these protocols use what? TCP at transport layer, and DHCP and TPDNS, these protocols use UDP at transport layer. Here segmentation can be done. Here segmentation can not be done. Now question is, what is segmentation? What is segmentation?
Segmentation is nothing but that large file of data you can divide it into bits.
Yes. Suppose I have one computer.
Sir, sorry for interrupting.
Yes.
Sir, you can open the white search, sir, because UDP will be show. Because this is a live section, right?
Yeah, what you are saying?
This is a live section, right? I mean, this is the online section, right? You will get the capture of UDP protocol.
Yeah, I will show you the capturing as well.
Yeah.
Yes. Okay, what I can do in the Wireshark. Let me open my Wireshark.
But we don't know what is the capture of UDP, right? So that's what I asked. So sorry.
Okay. We can capture, link while sending data of DNS. And here you can see on Wi-Fi adapter there are some traffic. Yes or no? On VMware also there are some traffic. So I think my VMware is on. Let me off that first. Let me turn off my VMware. Yeah, EVNG is running there. Okay, so let me capture the Wi-Fi adapter. So see this traffic from my Wi-Fi interface, this traffic are coming out and going. Yes or no? So any UDP data you can
Yes,
open.
sir.
Let me open this one. Source IP address is what?
Sir, here how we can identify the traffic, because in the backend some of the services are running, right?
Yes.
But here I'm also using the YouTube. So
Okay.
how can I identify the which service is going to for the YouTube and which service is going for the
Destination,
Windows?
destination port.
Okay,
Destination, both are what? Random.
right.
Both are random means we are not, this is not traffic of well-defined protocol. This is not traffic of Google. Okay. Source IP address is this one. Destination IP. Okay. Leave IP address. Let me close this one. See the UDP header. Here is your actual data. This is my actual data. This is what? TCP UDP header. In UDP header, are you able to see any sequence number, guys?
No, sir.
No. But in case of TCP, let me open any TCP packet over here. This is acknowledgement. See, the destination source port is what?
443.
That means this is a reply,
HTTPS. Yes.
right? Reply which is coming from HTTP server.
HTTPA.
Source port is any random port number. Sequence number is this one. Acknowledgement is this one. And window size. Window size is
106.
10614. Means after this data, machine will send what? Acknowledgement. And the destination IP address is 192.168.1.7. This is IP address of my Wi-Fi adapter.
Sir, we have 4 light. I mean, sorry, it minimize this, sir. This coming.
Okay.
Yeah.
Tell me.
This is frame is nothing but like physical layer. Ethernet layer is a data link layer. Internet layer is the network layer. This is the transport layer, right?
Yeah.
This 4 layer we have to focus for my network engineer.
Yes.
Correct?
Yes.
Yeah. See,
This
first is
physical layer is also you don't need to focus. This is all about the physical media.
yes.
Only these 3 layer is important.
Data link layer, internet layer, and transport layer. Right?
Can anyone? Yes. Can anyone tell me this is which type of traffic it is?
Like source and destination, they are
It's a
giving
network
phone
layer,
number.
sir.
भाई
No,
ये
transport layer.
ट्रैफिक है किसका?
सेकंड लेयर का सर.
ये एक एक्नॉलेजमेंट है. दिस इज अ एक्नॉलेजमेंट
Acknowledgement.
segment. Yes or no?
Yes.
So actually server is sending acknowledgement to my computer.
Sir, sorry to interrupt you. I just want to know here, sir, which layer you are now studying.
Transport
Actually,
layer.
yesterday I missed that class.
Transport
That's why I
layer.
asked. Okay.
Okay. So here, if you can see, check the destination IP address. Destination IP address is 1.7 and this is the IP address of my computer. Anyone able to see the IP address of my WAN interface?
Yes, sir.
Where it is?
This is a 1.7, sir.
Yes or no?
Yes, sir.
Yeah.
Yes, sir.
Means someone have sent acknowledgement to my computer. And are you able to see sequence number here? Yes. So in case of TCP, we have sequencing. Means on each and every segment, machine will assign one sequence number. So receiver machine can arrange the data in actual format. Yes or no? And here is the flag. In this flag, you can see only acknowledgement bit is on. So that means it is an acknowledgement message. Done, Ramesh? Can I close it?
Yes, sir. You can close it, sir.
Okay. So now, segmentation. So suppose I have one computer over here. This computer is connected with one, let's say, router. right? And we have one server over here. Okay, guys, anyone can explain MTU? MTU. MTU stands for maximum transfer unit.
Okay.
Maximum
Transmission unit.
transmission unit. What do you mean by it? This is the amount of data that an interface can transmit. And by default, the Cisco interface MTU is 1500 byte.
Means we can
1500.
say that MTU is like bandwidth.
Bandwidth is different thing. MTU is the capability of router interface that can transmit the data. So it can, this interface of router can transmit up to 1500 byte data only. If you want to verify it, you can verify. See, I have access of router. Here you can run command. This is inactive. No. I don't have access now. By default, on Cisco devices, MTU is 1500 byte and MDU is maximum transfer unit. I am not telling that this router cannot accept the data whose size is more than 1500 byte. I am saying this router cannot transmit the data whose size is greater than 1500 byte. Because MTU of both interfaces is what? 1500 byte. Done.
Sir, what about that other vendor?
You can check it on Google. I don't know about the other vendor, brother.
Okay, sir, okay, no problem.
We can change it as well. Right? This is, I am talking about the by default. MTU is changeable value. We can change it. So IP interface F0/0. What is MTU? 1500?
1500, yeah.
Yes or no? That means this router cannot transmit data whose size is more than 1500 byte. So here suppose I am using which service? UDP. Between source and destination. This is my source, computer is my source and server is my destination. Yes or no? So between source and destination my service is UDP. Okay. So there is no three-way handshake. There is no sequencing. Suppose this machine will send one data whose size is what? 2000 byte. What will happen, guys? At router, this data will discard. Yes or no? Router will discard this data. Router can accept it because what I am saying, MTU means maximum transfer unit. So it will check the MTU of my interface is 1500 byte and I am getting a data whose size is 2000 byte. Oh, I cannot send it. So router will discard it. Yes or no?
Yes, sir.
So because computer cannot send data of more than MTU size, for that we have segmentation at transport layer. But segmentation will be done in TCP only. Now question is, what is segmentation. So segmentation is nothing but a process of dividing a large size of data into multiple small part of data.
Sir, is it possible to change that value 1500 bits?
Yeah, it is possible.
Okay, sir. Thank you.
Now here MTU is 1500 byte. If you want to change it, you can change it on interface F0/0 IP MTU. Let's say 100. So IP interface F0/0 MTU is
Yes, 100 bits.
done.
We can increase that number, sir. 1500.
Yes,
apart
we
from
can
1000.
increase it as well in GNS3.
Okay, sir.
Interface F0/0 IP MTU. You can configure it from here to here. So you cannot increase more than 1500. 1500 byte is maximum. Okay.
Okay, sir. Okay. Got it.
Done. So segmentation is a process. It is an process of dividing. Why we are dividing, guys?
Because the speed, sir.
Because the package size have more than 1500 bits, right? So that's why we are dividing into
Yeah,
small parts.
suppose computer is sending one data to the server and router is dropping it. That means, I am utilizing the bandwidth of this link. Yes or no? I am utilizing the bandwidth of this link and I am not able to send data to server. So if my data is dropping on router, so it will be better if data will drop on computer itself. Yes or no? So that's why computer will divide the data on the basis of MTU. First, computer have to negotiate the minimum MTU between source and destination. But it will happen only in case of TCP, not in UDP. So now if application layer is generating data whose size is 2000 byte, because at application layer there is no any boundation. Application layer can generate any size of data. So suppose application layer have generated data whose size is 5000 byte. Okay, whose size is 5000 byte. Now if here we are running what? TCP, then definitely computer will divide it. But if we are using UDP, then also computer will divide it, but without negotiating the MTU. In case of UDP, it is predefined that it will divide data in what will be the size of one data. Okay, guys. But in case of TCP, now suppose I am using what TCP over here. So in case of UDP, my data can be dropped at router also. It is possible. Yes or no? Because suppose MTU on router is 100 byte. So computer don't know about the MTU value of router 1. So suppose computer will divide data into 200 byte. So all data will drop at router number 1. But in case of TCP, while three-way handshake, sender and receiver will negotiate the buffer memory. Sender and receiver will negotiate the not buffer memory as well, and MTU as well. Will negotiate MTU. Okay. Now suppose I have not only one router. Between source and destination, suppose we have 3 router. Okay. And here I have one computer, and here I have one server. Guys, suppose let's say MTU of this interface is 100 1000 byte. MTU of this interface is, let's say, 700 byte. MTU of this interface is, let's say, 1200 byte. Done. Done. MTU of this interface is, let's say, again 1000 byte. MTU of this interface is, let's say, 900 byte, and MTU of this interface is, let's say, 400 byte. Done. So tell me, if computer will send a data whose size is 1500 byte, will it reach to server? Will this data reach that server or not?
No.
Yes, it's reachable, sir.
No, it will not reach. At which
Because
device it will drop?
Yeah, 1000 is there.
Mhm.
1000 MTU is there
Suppose
capability.
this one is my router 1, this is my router 2, this is my router 3. So I am asking you, at which router your data will drop?
R1.
Router 2.
Router 2, router
R1.
1. How router 1 can transmit 1500 byte data if their MTU is 1000?
1000.
router
this
3,
data-
sir, because,
R1 drop the traffic.
Yeah, R1 will drop it. Okay, this time I am sending a data whose size is, let's say, 1000 byte. So tell me now, at which router
R2.
this data will drop?
R2.
R2.
R2. If data size is 500, tell me,
R3. R3.
now will this data reach to server or not? First of all, tell me that.
No. Not.
Yes. Why not?
R3 capability is 400.
It will send to router 1. Router 1 will exit this data from this interface, yes or no? And
Yes.
MTU
Yes,
of
sir.
this interface is 1000 bytes. So yes, it can transmit. Then router 2 will receive it. Router 2 will check. MTU is what? 700 byte, and data size is 500 bytes. So it can transfer from here also, transmit from here also. When router 3 will receive, router 3 will check, my MTU is 1200 byte, because router 3 will exit it from this interface, yes or no? So it can
sir,
transfer this data. But when server will generate reply, then reply will receive by router number 3, and it will discard the data, yes or no? Yes or no?
Yes, sir.
So we are using which service? TCP. So it is not going to send 500 size of data. First of all, both machine will negotiate their MTU between sender and receiver. Suppose there are 1000 devices between sender and receiver. It will check the MTU of all devices, and it will elect the least MTU. May I know the least MTU between source and destination?
400.
Yes, least MTU is 400 byte. So now computer have knowledge that whenever I need to send data, I need to divide data into multiple parts, and size of one data will be what? Max to max 400 byte. Yes or
400.
no?
Yes.
So if now computer will not generate any data whose size will be greater than 400 byte. So this is what? This is segmentation. Now suppose a computer have received one data from application layer whose size is 1000 byte. So transport layer will divide this data into how many part, guys? It will divide it into segment 1. In this segment, what will be the size of data? Let's say 400. 400. In segment number 2, it will send 400 data. And in segment number 3, it will send how much data?
200.
200. So actually transport layer is doing what? It is dividing. Yes or no? Large
Yeah.
size of data into multiple part of data, and on each segment it will provide what? Sequence number. So here sequence number will be 1, here sequence number will be 2, here sequence number will be, let's say, 3, right? So even receiver machine will receive segment number 3 first. They can arrange it. Done. Now hope it is clear to everyone difference between TCP and UDP. Yes or no?
Uh, Sir, I
Yes,
have
sir.
one doubt.
Yes. Go ahead.
Sir, the default 1500 bytes is fixed, right, in every source and destination.
Okay.
Okay, I'm going to send 1 GB,
1 GB data.
1 GB data.
Okay.
Okay,
Yeah.
because it's divided to 2500 bytes to router 1000 by 1500 bytes to 1500 bytes 3, right? Like that, right? I
Yes.
mean, sender.
Yes.
Okay, sir.
Okay. Now. Now. This is my computer. Again, this is my server. And between computer and server, there are a router. Okay. So suppose application layer is generating what? One data whose size is 2000 byte. Okay. At transport layer, what transport layer will do? Transport layer will divide this data into two parts. Yes or no? So guys,
Yes,
size
sir.
of one segment will be not 1500 byte, because with actual data transport layer is going to add their header, and as you know the size of transport layer header is 20 byte. Yes or no? In the same way network layer will also add one header, and size of that header is also 20 byte. So total number of external information that this layer is going to add is 14 byte. So size of one segment will be 1460 byte only. 1460 byte. Done. After that, here
So,
transport layer will
sir,
add 20 byte information and network layer will add 20 byte information. So total size of this segment is what? 1500. Yes, tell
so the
me.
application layer is generated to 2000 byte, means it will be sent like 1500 bytes only to router. Router will be sent to server in 1500 bytes only. The remaining bits will be sent to second segment, right?
Yes.
Okay, sir.
So remaining how many bits are there? How many bytes are there? 540?
Five.
Yes or no?
Yes, sir.
540 or 440?
540, it's
400.
right.
And
Yes, correct, sir.
transport layer will add 20 byte information and network layer will add 20 byte information. So total size of segment 1 will be what? 1500 byte. Total size of segment 2 will be what?
15x.
580
15. Yes, sir.
byte. Yes or no? Total size of segment number 2 will be 580 byte. Guys, at application layer we call data to data only. At presentation layer also we call data to data. At session layer also we call data. But at transport layer we call data to segment. What is the meaning of segment? Segment means your
Dividing
actual data, yes, small parts of actual data plus
sequence.
transport layer header. Okay, first transport layer will divide data into a smaller part. After that it will add transport layer header. Transport layer header can be, it can be TCP or it can be UDP. Done.
Okay, sir. Done.
Now, before discussing the TCP or UDP header, let me make you understand network layer. So guys, like transport layer is responsible to provide what? Source port and destination port. Network layer is responsible to provide
Source port to destination port IP address, sir.
source IP and destination IP address. Okay. And like network layer is responsible to provide source IP and destination IP with the help of header. Data link layer is responsible to provide what? Source MAC and destination MAC. Source MAC and destination MAC. Done. Address.
Yes, sir.
Okay, so now see the flow. I have one computer over here and I have one server over here. Domain name of this server is, let's say, www.pmnet.com. Okay, so here in the browser I am typing www.pmnet.com. At application layer will do what? Application layer will generate one
the traffic.
HTTP data. Yes or no? Yes or no? HTTP data.
Yes, sir.
After that, application layer will hand over it to presentation layer. Yes, definitely. Presentation layer will do what? Whatever task presentation layer need to perform, they will perform. After that, it will hand over to
formatting the data on the basis of compression, decompression.
It will hand over to yes. After that, it will hand over to session layer. Yes or no?
Yeah.
Now session layer. When session layer will receive this data, session layer will also perform some task, like it will maintain the table, it will create the session table. After that, it will hand over to transport layer. Now from here your actual work starts. See what transport layer will do.
To define the destination and source port.
First of all, transport layer will divide this data into a smaller part. Suppose this is a smaller part of data. Okay, this is a smaller part of the data. Let's say this is sequence number 1, segment number 1. Let's say data. Okay, this is not entire HTTP data, actual data. This is a small part of data. After that, with this smaller part of data, transport layer will add one header. Yes or no? It can be TCP header or it can be what? UDP header. In the TCP header or UDP header, it will provide source port and destination port. Source port. Let's say source port is what? Source port is, let's say, 1025, and destination port. Destination port is what? Let's say 443. Done. And now we call it as segment. This is your what, guys? Segment. Segment means your actual data plus transport layer header. Yes or no? Now transport layer will hand over this segment to network layer. Yes or no? Suppose the IP address of this computer is 10.1.1.1. IP address of this server is, let's say, 10.1.1.2. Now network layer will do what? Network layer will receive a segment. Network layer will receive one segment. Segment. With the segment, network layer will also add one header. Suppose at network layer, the routed protocol which is running is IPv4, so it will add one IPv4 header. If the routed protocol is running IPv6, so it will add IPv6 header. Inside the header, there will be source IP and destination IP. Source IP will be what? 10.1.1.1. Destination IP will be what? 10.1.1.2. Yes. Now question is, who will tell to this machine about the destination IP address? You are telling. You are writing www.pmnet.com in the browser. So first thing that your machine will do is, machine will resolve your domain name into IP address. And at network layer will add one more information there, that is nothing but the protocol number. There is one field called protocol field, and here there will be information about the upper layer protocol. So at transport layer, if we are using TCP, so here will be the port number of TCP. At transport layer, if you are using UDP, so here port number will be the port number of UDP. So in my case, I am using TCP. Done. So in the protocol field, there will be protocol number of application layer. Okay, so this is your packet. What we called it? Packet. Packet means what? Segment. Segment is actual information for network layer. Yes or no? So actual data plus IP header is called packet. And guys, these are, form of data at particular layer. What we call it? PDU. PDU means protocol data unit. The form of data at particular layer. So form of data at transport layer is segment. Form of data at network layer is packet. And packet means actual data plus IP header. Segment means actual data plus TCP or UDP header. And after that, network layer will hand over this packet to data link layer.
Data link layer.
Yes or no?
Yeah.
Now what data link layer will do?
Provide source
Data link layer have received one packet.
Frames.
Packet.
Packet.
Network layer will hand over packet to data link layer. Yes or no?
Yeah.
So data link layer will receive one packet, and data link layer will add their own header, data link layer header. If you are using Ethernet link for communication, so it will add Ethernet header. Inside the Ethernet header, there will be source MAC and destination MAC. So suppose MAC address of computer is A, MAC address of server is, let's say, B. So inside the data link header, there will be source MAC A, destination MAC B, and there will be one type field. In the type field, again there will be information about the upper layer protocol. So at upper layer, which protocols you are running? IP. This is IP header. So here there will be information about IPv4 protocol. Or if you are running IPv6, so here will be information about IPv6. Done. Then data link layer will hand over this to physical layer. But what we called it? What is the form of data at data link layer? It is frame. So frame means what? Actual data plus Data link header.
Segment plus packet plus.
Yes or no? And now data link layer will hand over it to physical layer. And physical layer will do what? Physical layer will convert it into bits.
Binary.
Yes, into bits, and then into signal, and then it will transmit from the link. Yes or no? Yes or no?
Yes, sir.
So when server will receive it, server will receive at which layer? Server will receive this data at which layer? At physical layer. Yes or no? Server will receive it at physical layer. So what physical layer will do? Physical layer will convert it, signal into bits, signal to bits, and bits into frame. And then this layer, physical layer, will hand over the frame to which layer? To
Data
Frame into
layer.
packet.
to data link
Frame
layer.
link.
Data link layer. Now data link layer receive one frame. Yes or no?
Yeah.
So data link layer have one frame. Now data link layer will open this frame. So if data link layer will open this frame, guys, what will be the information inside the frame?
Packets.
Inside the frame, here you can see these information are there. Yes or no? So see, this is the detailed information inside frame. Yes or no? Now data link layer will check the destination MAC address first. Destination MAC address is what? B. First of all, data link layer will check that destination MAC address is my MAC address or not. In only two cases, data link layer will accept this frame over here. If destination MAC address is the MAC address of server, or destination MAC address is broadcast. In only two cases, data link layer will accept this frame. Done? Because if someone is sending a broadcast message, that can be also for server. Okay, so destination MAC is what? B. So okay, someone have sent data for me only. If destination MAC is, let's say, C, then data link layer will discard it at data link layer, at layer 2. Done, guys? Done?
Yes. Yeah.
Now, so destination MAC address is the MAC address of server. Okay, so someone have sent, data link layer will think that someone have sent traffic to me. Yes or no? This is frame for me. So data link layer will actually remove this header. Which header? Data link header only. And it will hand over this packet to upper layer, to network layer. Yes or no? Network layer. Now network layer receive one packet. Again network layer will do what? Network layer will open this packet in detail. And these are the detailed information of packet. Yes or no?
Yes.
It will open it in detail. And then it will check the destination IP address. In only two cases it will accept. Network layer will accept if destination IP address is my own IP address or it is broadcast. So destination IP address is what? 10.1.1.2. Done? This is my IP address. Yes or no? That means someone have sent packet to me. Yes or no? So it will accept it at network layer. Then it will check the protocol field. Inside the protocol field there will be information about upper layer protocol. In the protocol field, if protocol number is of EIGRP, so it will hand over actual traffic to EIGRP. If inside the protocol protocol number is of OSPF, so it will hand over to OSPF. If protocol number will be the protocol number of TCP, then it will hand over to TCP. So in my scenario, in protocol field, value will be the port number of TCP. So what network layer will do? Simply network layer will remove this header, the network layer header. Okay guys, and then it will pick the segment and it will hand over the segment to the upper layer protocol. And which protocol is running at upper layer? At transport layer? TCP. So it will hand over this segment to transport layer. Now transport layer will receive one segment. Done. Is it clear guys till here?
Yes,
Now
sir.
transport layer will
Yes,
open
sir,
this
yes.
segment in detail. So this is the detailed information of segment. Yes or no? It will check what? Destination port number. Destination port number is what? 443. Transport layer will check that 443 service is running on me or not. So yes, 443 service is running on me. If 443 service is not running on me, transport layer will discard it over here. If 443 service is running, then simply transport layer will remove the header and it will hand over the actual data to session layer. Session layer will hand over to presentation. Presentation layer will hand over to application. And at application, you can see the data. Yes or no? So this will be the flow. So see, what I am trying to explain over here is, while transmitting on each layer from transport layer to data link layer, what layer are doing? Layer are actually adding extra information. Yes or no? Adding extra information to send the data to actual destination. Yes or no? Yes or no? And while receiving, receiver machine is doing what? It is removing the extra information which sender have add with data, because receiver machine also need to deal with the actual data. These extra information are only to send the actual data to the right destination. Yes or no? So receiver machine is removing the extra information. Removing extra information from actual data.
Or else we can pronounce removing header, sir.
Done. Now always keep in mind, adding extra information with data is known as encapsulation. This is also a very popular term in networking. And removing extra information with actual data is known as decapsulation.
Decapsulation.
So what do you mean by encapsulation? Interviewer can directly ask you, explain encapsulation. So encapsulation is a process of adding extra information with actual data to send the actual data to right destination. What is decapsulation? Decapsulation is removing extra information from actual data. Yes or no? Sender machine always perform encapsulation. Receiver machine always perform what? Decapsulation. Guys, tell me, is it clear?
Yes, sir.
Everyone? What about others?
Yes, sir.
Yes.
Okay. Now we have discussed these all things. Data link layer. Here also you can read the network layer responsibility. Network layer provides logical address. Logical address means IP address. Okay. Router and layer 3 switches work at this layer. The main function of router. Yes, yes. Tell me.
Yes, sir. Can you share this?
Yeah, yesterday also I have
document
shared
to us?
this. Yesterday also I have shared it in group. You can check, brother.
No, I think I already checked, but I didn't see that one, I guess.
Really?
This, yeah, in this one.
This one here you can see.
Just it. Which one, sir?
Yes, last one, this one.
Oh, okay. It is one side inside then. What is in? What is the
What is
network?
network?
Okay, okay, okay. Thank you.
Okay. Now
No, thank you.
we have discussed PDU as well. Data, segment, packet, frame, bits. Okay. Encapsulation, decapsulation. Now we have TCP IP model. So guys, the difference between OSI model and TCP IP model is, first of all, OSI model is a theoretical model. It is just a theory, and TCP IP is a practical. There are some, there are only 5 layer in TCP and there are 7 layer in OSI. But whatever task performed by application layer, presentation layer, session layer in the OSI model, same task will be performed by application layer in the TCP IP model. Okay. Whatever task performed by the transport layer in TCP, same task will be performed by transport layer over here. Whatever task performed by the network layer in OSI model, same task will be performed by internet layer here in the TCP IP model. Same for data link layer as well and physical layer. Now the topic is TCP header. So inside the TCP header, see, router will or machine will add these information, these all information. Source port will be there, destination port will be there, sequence number will be there, acknowledgement number will be there, header length will be there, reserve, flag, window size, checksum and urgent. These all are the field of TCP header. Means if a device is adding TCP header, they will add these all information with actual data. These are extra information. Done. So here we have mentioned all, definition of all fields. So if you have anyone have any problem in any field, you can read. Done. Like source port, it is an 16 bits value, destination port sequence number, a number used by the TCP that puts the data back in the correct order or retransmit missing data during the process called sequencing. Acknowledgement number, header length, it is the size of TCP header. But data, urgently we can put priority on the data. Like on an ambulance, we are giving one priority by putting one signal on the top. Yes or no? On the road, how you are differentiating ambulance from other car? Done. After that, there is one option field also for the future use, or for now also. If you want to send some extra information in TCP header, you can use option field. Then UDP header. Inside the UDP header, there will be source port, destination port, header length, checksum. Only 4 information will be there inside the UDP header. Inside the IP header, there will be information about the version, header, priority, total length, identification. So this is also important. We need to discuss, identification as well. It will take some time. So that's why today I'm not starting it. Later on, we will discuss this also. Then flag, fragmented offset. After that, TTL, time to live. What is TTL, guys?
Time to live.
Yes, time to live. What is time to live?
Time to live.
Time to live means we can source to destination means we have to access 255 routers in internet.
This is used to avoid layer 3 loop. Suppose I have a topology like this. Router 1, router 2 and router 3. If you guys have knowledge about routing, suppose here I am running one network 10.1.1.0/24 and here is one user whose IP address is 10.1.1.1. This router is, let's say, here. Suppose I have one, don't worry, leave. Suppose router 1 have root for a network towards router. Suppose here I have configured a default route 0.0.0.0 toward router number 2. On router number 2 I have configured one default route 0.0.0 towards router number 3. Here I have configured a default route toward router number 1. So now if router 1 will receive a packet where destination is anything, suppose destination is not available in the routing table of router 1, it will forward traffic to router 2, router 2 will forward to router 3, router 3 will forward to router 1, again router 1 will forward to router 2, right? Like this traffic will be moving between these router, yes or no? For lifetime. In upcoming day, when you will understand routing, you will come to know that how loop can form in the network. Now it is difficult for me to make you understand how loop can form. But suppose here loop can form. Here we have a loop in the topology. So traffic is moving. And we don't have any option to avoid this loop. That's why we have what? TTL value. So on a router, whenever a packet cross router, it will decrement TTL value by 1. Whenever a traffic cross a router, it will decrement TTL by 1. Actually, first, whenever router will receive any traffic, you know what router is processing traffic, it will check the destination. If destination is router itself, then it is not going to check TTL value. But if destination is not itself, then it will check TTL value. And it will decrement TTL by 1 and then it will forward to their neighbor router. So once TTL value will become 0 on a router, that router will discard the traffic. So don't worry, in upcoming day you will understand TTL value as well. Then there is one protocol field. This is very important field. In this field there will be information about the upper layer protocol. After that source IP, then destination IP, then option and data. These are information of IP header. Done. Now let me ask you some question. Okay, suppose this is my computer, guys. My computer is connected with one switch and this switch is connected with one router. Done. And on this router I have enabled telnet, so I can take remote access of router 1. So what I will do here, I will run command telnet. Suppose IP address of router is 12.1.1.1. IP address of this computer is 12.1.1.10. So I will run command telnet 12.1.1.1. So telnet is a application layer protocol. Yes or no, Arun?
Yes.
Telnet is an application layer protocol. So application layer will generate one telnet request. Work of application layer is done. Now it will hand over to presentation, session, and then transport. Transport layer will do what?
Add the source address.
Source port and destination port. So source port will be what?
It's a random.
Random.
23.
Let's say 1025.
Yeah.
Destination will be 23.
20.
After that it will hand over to network layer. Network layer will add what? Source IP and destination IP. Source IP will be 12.1.1.1. Destination IP will be 12.1.1.2. Then it will hand over to data link layer. Data link layer will add source MAC and destination MAC. Source MAC is suppose A, destination MAC is B. So A and B. Done. Suppose here I have disabled telnet on router number 1. And then if I will run the command telnet 12.1.1.1, then also application layer will generate telnet request. Yes or no?
Yes, sir.
Now tell me at which layer this router will come to know that telnet is not running on me. I need to drop this traffic. Actually this router will receive this traffic. Yes or no? And it will discard it. But my question is at which layer router will discard this traffic?
Network layer.
Network layer, it will check destination IP address. So destination IP address is 12.1.1.2. Oh, sorry,
Transport layer.
12.1.1.1. It will be 2.10. So yes, at network layer, IP address is my IP address is mine. So I will not discard it. I will hand over it to upper layer. No, Ramesh, you are absolutely wrong. Tell me guys, tell me. At which layer router will discard this telnet traffic? At transport layer, when it will check destination is what? 23. It will check that this service is running on me or not. If this service is not running on me, then definitely I will discard it. So at transport layer, router will discard it. Now guys, let me show you the actual flow here. Here what I am going to do on router number 2, first of all let me capture the link, and I am going to send one telnet traffic from router number 1. By default telnet is enabled or disabled on router?
Sir, it is disabled.
Enabled.
Sir, IPSS server we should have to enable in the router.
No, by default telnet is enabled.
Okay.
Okay, so this is capturing. Now from router number 1 I am going to send one telnet traffic. Telnet and IP address of router 2 is, okay, I have not configured router 2. Config T interface F0/0 no set and IP address. What IP address I am running on router 1 guys? So IP interface brief 10.1.1.1. So on router number 2 let me configure 10.1.1.2. Okay, first of all tell me, if I will ping 10.1.1.2 from 10.1.1, will transport layer work guys? If I will ping 10.1.1.2 from here, will transport layer work? No. What is ping? Can anyone explain ping?
So ping is a command.
Ping is an utility which is used to check connectivity between two devices. So if I am writing ping over here and I am entering, so if my router is generating traffic automatically, that means definitely one protocol is responsible for it. Behind scene, one protocol will work. May I know the name of that protocol?
ICMP.
ICMP. And ICMP work at which layer? ICMP works at layer 3. So ICMP will generate traffic at which layer? At layer 3. So where is transport layer? Transport layer is layer at layer 4. So if you will ping 10.1.1.2 from here, you can see in the capturing also, there will be no transport layer. This is your actual ICMP traffic, then network layer, then data link layer, then physical layer. Okay. Because this time my actually computer or router is generating traffic at layer 3. Okay. So flow will be different. Here traffic is generating at which layer? At layer number 3. So at network layer, ICMP protocol will generate ICMP request. At same layer, it will hand over to IP protocol. IP protocol will add source IP, destination IP. Then it will hand over to data link layer. It will add source port, source MAC, destination MAC. Then it will hand over to physical layer. So in this packet in ICMP, if you will check the IP header, inside the IP header there will be one protocol field, and inside the protocol field protocol number will be 1. Protocol number 1 is reserved for ICMP. You can check it on Google. ICMP protocol number. Yes or no? So this is how router 2 will came to know at network layer that this is a traffic of ICMP protocol. Getting my point, guys? First of all, see, let me make you understand again. See, this is your actual ICMP traffic, yes or no? This is your actual ICMP data. Okay. So at network layer, what is happening? At network layer, ICMP will generate one ICMP request. Done. This is your actual data. At which layer? At layer 3. Done. After that, it will hand over to IP protocol. IP protocol will do what? IP protocol will add IP header. Inside the IP header, it will add source IP. So source IP will be what? 10.1.1.1. Then it will add destination IP. Destination IP will be 10.1.1.2. There will be one field called protocol field. Inside the protocol field, there will be protocol number of that protocol which is generating this traffic. Who have hand over this traffic to IP protocol? ICMP. So there will be protocol number of ICMP. Then it will hand over to data link layer. At data link layer, Ethernet protocol is responsible. Actually, ARPA protocol is responsible over here. We are using Ethernet, so ARPA will be responsible. ARPA protocol will add what? Source MAC. Source MAC is, let's say, A. Then destination MAC. So destination MAC is, let's say, what? B. And there will be one field called type field. And in the type field, it will add the information of upper layer protocol. So who have hand over this traffic, this frame to data link layer? IP protocol. So there will be information of IPv4. Done. This is your data. When router 2 will receive it, at layer 2 first it will check what destination MAC. So destination MAC is B. See, first of all, here also at network layer, source IP 10.1, destination IP 10.2, protocol number 1. At Ethernet header at layer 2, source MAC, destination MAC, and type IPv4. There is information about IPv4, yes or no? So when router 2 will receive it, at layer 2 it will check destination MAC address. So destination MAC address is B. Then it will check type field. Type field is what? IPv4. So it will remove layer 2 header and it will hand over the packet to network layer. At network layer, IP protocol will receive it. IP protocol will check destination IP. Destination IP is what? 10.1.1.2. Okay, this is my IP address. Now let me check protocol field. So protocol field value is what? 1. So it will IP protocol will directly hand over to ICMP protocol. And ICMP protocol will see, oh, I have received one ICMP request. So I have to generate what? Reply. So ICMP request, for ICMP request, there is one type. See, the type is what? 8. Whenever type is 8, that means it is an request. And in the reply, see who is generating this traffic? 10.2. In the reply, type will be what? 0. Okay. and here also everything will be same. But if I will send telnet traffic from router number 1, so telnet traffic is an application layer protocol. So let me send telnet traffic now. Telnet and 10.1.1.2. See the telnet traffic. Before sending actual traffic, first machine build logical connection, yes or no? And here you can see this is your actual telnet traffic. Yes guys, this is my actual telnet. This is TCP header. Inside the TCP header, source port random, destination port 23, sequence number, okay, window size, leave these things. Transport layer, after that network layer. See, in the network layer, source IP 10.1, destination IP 10.2, and protocol TCP. So network layer will hand over this segment to TCP protocol at transport layer. Guys, layer will never accept traffic. Actually, the protocol which is working at that layer, that is responsible to accept traffic. Yes or no? Transport layer is nothing. Actually, TCP protocol is there. Who is responsible to encapsulate and decapsulate the traffic? Okay. So here in the IP header, you are able to see protocol number is 6. So then only receiver machine will come to know that I need to hand over this to TCP protocol. Okay. And at Ethernet header, you can see the type. Where is type field? Okay. This is type code of IPv4. This is type code of IPv4. So interviewer can ask you different questions from this topic, like they can ask you that if I am pinging router 2 from router number 1 at network layer, how router 2 will came to know that I have received a traffic of ICMP? So what is the answer? By checking the protocol number. They can ask you that here I am running telnet and from router number 1 I am trying to access router number 2. Okay, at network layer, this router will check what? Destination IP address. Then it will check protocol field. Then it will hand over to transport layer. Now, how transport layer will came to know that this is a traffic for telnet? So by checking destination port number, yes or no? So this type of question interviewer can ask you guys from this topic. In next video, we will understand packet flow, and directly then we will move to routing. If anyone have any doubt, here you can ask.
Okay, sir.
Guys, recording is do you guys need recording of this class?
Yes, sir. We need. Yeah. So we need.